you know, we spent, obviously, I know we spent a large portion of the class on that first 20 to 30 minute stuff. We got through that, we made the decision, the flight's legal to go, we've got good weather, there's no MELs, we've got an ETD of 0030 Zulu. We then jumped in, we did the weight and balance, we got all that stuff done, we did all the runway selection charts. So basically, we're all the way up to the point where we start the simplified flight planning, okay? So we've done the legal to go, does it need an alternate, looking at the NOTAMs, runway selection, weight and balance. That's basically what we've done. We've come up with our route. How do you guys feel with everything up to that point? Just generally speaking, whether it be this flight plan or other ones of the plan.
I'm okay with that.
Are most of your guys' questions and concerns basically from this point forward,
Yeah, I mean.
what we're doing? Okay.
Anything before now is just remembering the correct order to put stuff in. Like I know
So
how to
is this
do
one
all
we're
of it. It's
supposed
just
to do,
remembering
like,
when to do
all
what.
together, because
Once we
I didn't
get to
have the
here
packet.
forward,
I only had a computer.
Yeah. Okay.
It's more following along.
So, like I said, we've come up with the route. We've got all that. We've figured out everything as far as runways, weather. I mean, it's a pretty straightforward plan. There's no issues with MELs. There's no issues with weather. There's no issues really at all, other than just computing the flight plan and doing all the things that we need to do there. So, okay, so we're gonna jump into the simplified flight planning. Do you guys, I know you guys have already been doing this. So the simplified flight planning is basically kind of the beginning of when we start gathering all the data, okay? And like I was saying the other day too, like there's little differences probably that Garrett might have. Not that one way is better than the other. You know, one way may work better. Just, you're gonna see it my way, obviously, when I do it. You're gonna see it his way when he does it. Just figure out which way works best for you. So, but this is obviously where we do our, you know, our little, it's where we're doing our little, okay. I will tell you right now that Garrett has much better handwriting and drawing abilities. So, representing our climb, en route portion, descent portion. There's obviously a bunch of data that we gather for this portion, that portion, and the descent portion. So this is just the easiest way to do it, in my opinion, like mapping it out so you know what part you're looking at, what it is. Starting out in San Diego. Okay. So we've got the weather here for San Diego. The very first thing that we want to figure out is we want to figure out our temperatures and our elevation for our origin and then our destination. Real important. Okay? So San Diego, what's the temperature in San Diego? 17 degrees, okay. Anybody ever been to San Diego? What's, it is.
70.
What's the elevation of San Diego?
17.
Anybody tried on the water, right? So, I'm not too worried about jumping into the charts and looking up the elevation of San Diego. In other words, I know that it's sea level. So, if San Diego is at sea level, and it's 17 degrees, what's what are we looking at as far as ISA goes?
2 degrees.
ISA plus 2 is the temperature.
But we're using-
ISA plus 5 is the chart. Okay? So yeah, so it's ISA plus 2. So what I want you guys to just be able to develop as we kind of move through this stuff is, obviously, when we look at things, there's some of these things have a lot of steps, right? And sometimes the steps are easier, sometimes they're harder. It really just depends on what the data is we're looking at. But one thing that I kind of notice, and this is over several classes of teaching, is I think sometimes we get a little wrapped up in the steps and the procedures. And I know to an extent you do have to memorize things, and you gotta get familiar with things. But what I think happens in the end is that we end up overutilizing the steps. Not that, like I said, there are some things that you do have to go in order. However, I think it causes us to sometimes send common sense out the window. When something could be done really easy just by looking at it, we end up going through a 5-minute process to figure it out, when you could probably just look at it and figure it out in 30 seconds. So that's kind of where I was saying, like, we need to simplify things a little bit. It's easier said than done, but pretty much everyone in here knows that San Diego is at sea level. You know that ISA at sea level is 15. You know that this temperature is 17. So it's obviously it's really quick to be able to say, oh, ISA plus 2, that means ISA plus 5 with the chart. So just little things, little tiny things like that we can do fast. Okay, so we're ISA plus 5. This is all we care about as far as the data goes for this airport. Okay, we've already looked at the runway, we already looked at the winds, we've already done that part. So we know that we're taking off on runway 27. We know that the wind is 270, 10, gusting to 17. That part we already looked at, we already figured it out. We've already put it on the chart. What I see a lot of is putting the airport, putting the elevation, putting the temperature, putting the ISA deviation, and doing a lot of mathematics right here. And then, and this is kind of what I was telling you earlier, we end up getting cluttered with data. The only reason we care about the San Diego temperature and elevation is to get this. So if you have this, then don't put other information there, if that makes sense. You want to know, okay, we're San Diego and it's ISA plus 5. That is the only reason we, like I said, we cared about the temperature. But, a lot of people will, do a 17 degrees and it's like 25 feet above sea level. And it kind of just starts, when you have to go back and reference stuff, you start seeing all these numbers like, oh, what did that mean? And does this go, maybe that goes there, and it just starts getting discombobulated. So when you figure something out, like on this chart, when you're gathering data, if you want to use like a scratch paper that you just use it for just scratch and leave it away from your stuff, like there's like stuff like this where you chart out and you kind of go back and reference things, but you're just going to want just the information you need on these charts. Okay, so ISA plus 5. That's basically telling us that we're going to use the ISA plus 5 climb out chart out of San Diego. Portland. Portland, does anybody know the elevation of Portland? I know a few of you do.
0.31.
It's 30 feet, yeah.
30
feet. So it's sea level as well. So therefore, what's our ISA deviation for Portland?
15, and then the temperature.
Is it colder or warmer?
Is the temperature cold?
It's colder than ISO.
So the minus.
Yeah, so when I say what's ISA, the only possible responses are either starting with a plus or a minus, so either a +6 or a -6. If you just spout out a number, that's not gonna work. You gotta spout out plus or minus and then a number, because otherwise it's not telling us anything. So ISA what?
-6.
ISA -6. Okay. ISA -6, which means what chart do we use for that?
ISO minus 10.
-5.
Minus
-5.
5. Sorry. We always round up.
There you go.
Number line it if you have to.
I keep
This
on
is
thinking.
another, see, that's another one of those things, and this is, I mean, I do this when I'm teaching it, so I know that it's gonna be people, students are gonna do it. So it's just natural to not go the right way when you're using a negative number. But that's kind of why you just have to step back for a second, and honestly, if you just like call timeout when you're doing some of this stuff and just use a little bit of just kind of the practical thinking and just, okay, I know ISA -6 is what it is. And then on the chart, what's gonna penalize that more? We always go warmer. So ISA -5. So I know it, you're naturally gonna think ISA -10. ISA -5.
That's one of the things they gotta change quickly, or else we're always gonna get the wrong data.
So that is what we're gonna use for our descent. Okay? That's fine.
Yeah.
And if there's not a chart, then you just go to the next one if there is a chart.
Warm.
There may not be an ISA -5 chart. In that case, you just go to ISA. Just keep going warmer to the next chart. Okay. So we've got that information. Now, you know what? The only thing I didn't do is I never did winds aloft for this flight.
Okay, you want me to just go pull Winslow off right
Yeah,
now?
let's go grab winds aloft. While he's doing that,
You just want the whole chart, or should I narrow it down for him?
you can just bring up the whole chart. That's
Okay.
fine with that. Okay. Before we do that real quick, we're going to just take a look at this here. Okay, so you've got San Diego, you've got this ISA +5. When you get this information, when you know just this, and a little bit of stuff we've already done, such as the takeoff weight, we can figure out our climb capability. So maybe bring up the climb capability real quick.
This one?
Yeah, that works. So what is our takeoff weight?
I think it's 69711.
69,711. There's another one in here too, if you guys haven't seen it. Keep going down here. Keep going, keep going. A little bit more.
Oh, isn't it that? Oh, that's all.
No, it's
My bad.
down. It's right there. Right there. Okay, there's this chart too you can use. Sometimes people think this is easier. Altitude capability. So all you do here is you're going to take your weight. So we're 69,771. So we're going to round that up to 70,000. And Then we're gonna go deviation from ISO, we're ISO plus 5, so we're gonna be in this,
I lost you.
scroll up. Just leave it right there. So ISO plus 5 and 70, so match those two up. And that's gonna be our altitude capability is 39,158. So we know that we can go up to 39,000. So San Diego to Portland, we already did our straight heading, our average heading. Does anybody remember what that average heading was for this flight?
333.
That one was?
Yes.
Okay. So 333, if we're flying that as an average heading, what altitude would that be at?
So it's